Good evening, everyone. For today, I will discuss engineering economics. Engineering economics is divided into two topics. For today, I will be discussing the first part, which is about the principle of interest and some common cash flows. So, I will start with a very step in engineering economics, the simple interest. Let me consider an amount of 1,000 pesos. I equate it to P to mean that this amount is available right now. P means present. If this money is invested to a bank at the rate of, say, 10% per year, then we can say that at the end of the year, our 1,000 pesos will earn 10%. That is, 10% of 1,000 is 100. Okay, we can now generalize that the formula for the simple interest earned for every period is equal to I, which is equal to the principal amount, 1,000, in this case is P, times the interest rate, which is in this case is 10%. Let us consider this timeline for our investment. So let's say that at this period, we deposited 1,000 to the bank, and a year after, our money in the bank will earn 10% or 100 pesos. Another year, our 1,000 will earn another 100 pesos. In the case of the simple interest, it is only the principal amount that earned an interest. So, for the first, for the second, the interest is the same as well as on the third year. On the end of the third year, our money earned another 100, and so on up to the sixth year. Assuming that the term of the deposit is 6 years, then we can determine that the total amount earned by our money is equivalent to 6 times of the interest per year. Thus, we can say that the total interest earned by our money is equal to I sub n, where n is the number of periods, is equal to the interest earned per period, Pi, which is in this case, the interest earned per period, times the total number of period, n. Or we can simplify the formula further as Pi n. Now, at the end of the sixth year, we go to the bank and withdraw our money. How much is the withdrawable amount? For sure, we can withdraw the original amount of 1,000 pesos plus the amount earned by our money, which is equivalent to the 100 pesos. Meaning, we can now generalize the formula for the future amount withdrawable from the bank. Or we say that the future amount of money, if the interest per period is given by this formula. F, which means future amount, is equal to the principal amount, of course, in this case 1,000, plus the accumulated interest, which is in this case is the PIN. Or we can rewrite this formula as, since P is common in these two terms, we can bring P out of the parentheses and we have 1 plus IN. Okay, let us try this problem. 6,000 is invested at the rate of 12% per year. If the investment is withdrawn after 10 years, determine the total amount withdrawable. Okay, first, in this illustration, I will compute first the total interest, which is PIN, where P is 6,000. The interest is 12% per year, and the number of period is 10. Well, in this case, although the problem did not mention which kind of interest to be used, since this is a custom question, I intended it to be computed using the simple interest. That is why I use n is equal, I use the simple interest formula. Our n is 10, so we can now compute the total interest to be equal to PIN, where our P is 6,000, interest is 12% for a period of 10 years. And then we can compute the I to be equal to 7,200. Or we can also compute this. We can now compute the total future amount or the amount withdrawable after 10 years to be equal to the initial amount, which is the principal, plus the accumulated interest, or a total of 13,200. Of course, we can use the shorter formula, which is the formula we have derived earlier, to be F is equal to the principal amount times 1 plus I n. The same, we have the same amount of 13,200 pesos. Okay, let's try this one. Determine the ordinary simple interest on 6,000 for 9 months and 10 days if the rate of interest is 12%. Okay, so we are going to determine the ordinary simple interest. Okay, here's our formula to compute for the interest, where our P is 6,000. The interest is 12% per year. Now, our N, in this case, since the interest is expressed in year, although the statement did not indicate the period of the interest, it always means per year if there is no description attached to the interest rate. So, since the interest rate is per year, then our period N must be also expressed in year. Our period here is 9 months and 10 days. So, we must express that in years. 9 months and 10 days is equivalent to 9.33 months because 10 months is 10 out of 30 days in a month, or 0.333. Therefore, 9 months and 10 days is 9.33 months. 9.33 months out of 12 months in a year, this is the value of our n now. Our n is lesser than 1. It's valid to be used in our formula. So we can now compute the total interest earned by the money, 6,000 times 0.12 times 0.7775. So the total interest is 560. Okay, if you borrow money from your friend with simple interest of 12%, find the present worth of 20,000 pesos, which is due at the end of 9 months. Now, the problem states that the friend is willing to pay 20,000 pesos at the end of 9 months. Maybe this money is amount receivable by a friend, maybe from her salary 9 months hence. So this amount of money is the future amount we may receive from her or from him. The question is how much money we are willing to lend to this friend. So our F in this case is given. The present amount is unknown. This is the question, the amount of money we are willing to lend, and our N is 9, is a fraction of a year, equivalent to 9 months. Our F is 20,000. Our N, our I is 12% per year, and our N is 9 out of 12 of a year, 9 months and 12 months in a year. So we now compute the value of P. Substituting everything, we only have P as the unknown. So we may compute this using algebraic manipulation or using the shift-solve function of the calculator. Our P may be calculated uh, or calculate the value of P. Okay, so I will now proceed to the concept of compound interest. In order to illustrate the principle, I will consider an example. Suppose I have 10,000 pesos and it is deposited in a bank that offers an interest of 1% per year. This is uh, because the average interest offered by the banks are in the range of 0.5 to 1%. This is closely related to the actual interest given by the banks. Determine the total withdrawable amount after 5 years. So if you deposit 10,000 pesos now to the bank, how much is the withdrawable amount after 10 years? Or I mean after 5 years? Is it worth the time of saving your money in the bank? Could you consider this as an investment? Let's try computing it. Okay, so at the end or at the start of the year, you deposited 10,000. This amount of money after a year will earn 1%, meaning we can compute that the total amount of your money after a year in the bank to be equal to 10,000 times 1.01, where 0.01 is the 1% increase in the original amount of 1, or we have 10,100. Now, this 10,100 will serve as the principal amount on the beginning of the second year, meaning to compute the amount of money in the bank after 2 years, we have to compute the amount of money earned by 10,100. This is to increase by 1% again. Then we'll have 10,201 at the end of the second year. This amount of money, 10,201, will serve as the principal amount on the beginning of the third year, and the amount of money at the end of the third year will be 10,303. The same, this amount of money will serve as the principal amount on the beginning of the fourth year, and the amount of money at the end of the fourth year will be equal to this amount. And on the fifth year, the amount of money in the bank is equal to 10,510. Now, as you can see, the principal amount is 10,000. The final amount of money in the bank after 5 years is 10,510. Now, as you can see, there is a total increase of 510. Now, we can argue that 510 is the total interest earned by your 10,000 for a period of 5 years. The question is, does 510 worth the time of waiting? It depends on the case or depends in situation. Well, in my case, 510 is a very small amount because if we consider the average inflation per year is 4%, then at the end of the 5 years, the amount of 10,510 has a lesser capacity to buy goods such as, for example, rice. Okay, we may also compute the total amount after a year or after 5 years using this formula. 10,000. After a year, it will yield 1%. After a year, this entire amount will earn 1%. And this entire amount, after a year, will yield another 1%, and so on, until we get until we have 5 years. Meaning, in order to arrive to the fifth year, we multiply the principal amount by 1.015 times. Or, using the algebraic notation of exponent, we can write it as 10,000 times 1.01 raised to the power of 5, and that is equal to 10,510. Let us now formalize the formula for the compounded interest. Assuming that I have 1,000 pesos, the amount of money that is available right now, which I call P for present. Now, say if we invest this money in the bank at 10% per year, then this money for every period may be represented by this diagram. At the end of the first year, the amount of money in the bank is equal to 1,000 times 1.1. This amount of money will serve as the principal amount for the beginning of the second year, meaning at the end of the second year, that amount will increase another 1%. Or if I multiply this amount by 1.1, then I will have two factors of 1.1, and that will become 1,000 times 1.1 squared. The same story, at the end of the third year, this will be multiplied by another 1.1, making it a total factor of 3, 1.1, and so on up to the fourth, fifth, and the sixth year. Now on the sixth year, the total amount of money in the bank is equal to this amount. Our formula: the future amount after 6 years is 1,000 times 1.1 raised to the power of 6, which is equal to 1,772. Or, in general, the future amount of money after n periods is equal to the principal amount times 1 plus the interest per period, in this case is 10%, raised to the total number of compounding periods. Okay. For example, if we reverse the situation, for example, now I have withdrawn 1,772 money from the bank, and then the bank offers an interest of 10%. How much money did I deposit 6 years ago? So, in order to compute the amount I have deposited 6 years ago, I simply divide it by 1.1 raised to the power of 6. Take note that this formula is simply a rearrangement of the original formula above. Then we can compute that it is equal to 1,000. Or in general formula, we can rearrange this formula to solve for the present value P, and then our P is equal to this formula. Okay, let's try this problem. The Kaaba ministry promises a monthly return of investment at the rate of 30%. Assuming you invested 100 now, how much amount would be accumulated after 6 years? Okay, maybe you have heard of Kaaba ministry, and they are offering this investment scheme of a return of 30%. Let's compute the amount accumulated after 6 years for this 100 pesos. Okay, 100 pesos times 1.3. This is the 30% is an interest earned per month. And the total number of months it will compound is 72, because in each year there are 12 months and we have 6 years here, so 12 times 6 is equal to 72. So if you have invested 100 in this ministry, after 6 years, your money in their ministry will become 15,992,000,000. That's a lot of money. Okay, so if we divide it by 1,000, then we can determine how many peso bills is required or is required to be printed in order to pay an investor, which is you in this case. Okay, let's proceed. How long will it take money to double itself if invested at 5% compounded annually? Now, this is our formula for the compounded interest. Um, we have an I, which is 5%. The question is N. We don't have P, but we know that F is twice of P, because by that time the future amount is twice of the original amount P. So if we replace F by 2P, then we have this equation. We can eliminate P from both sides of this equation, and the only unknown here will be now N. So we may now solve for the value of N using algebraic manipulation or using the shift solve function of your calculator. It is found that N is equal to 14.2 years. There is another way of solving the value of N. Well, as you may notice, solving for the value of N using the shift solve function of your calculator may take longer time. So we may compute the value of N using another method, which is called the 72 rule. This rule is used to compute for the total number of periods to double an investment. This is how it is done. To compute for the number of periods for an investment to double, simply divide the number 72, a constant 72. It is always 72. That's why it's called 72 rule. Divide it by the quantity of the interest, without the decimal, without the percentage. So in this case, we have 5%, so we divide 72 by 5, and we get 14.4. So this is a rule of thumb to compute for the number of terms to double an investment. And now we will discuss the nominal rate, and we'll also differentiate it from the effective rate. Assuming a certain bank offers an interest of 12% yearly. When the bank says that the interest is 12%, it is not actually the actual interest. That interest is called nominal interest. This number is used as the basis for the computation of the actual interest. Thus, it is termed as nominal, and we usually represent it by the variable r. Okay, assuming that the bank offers an interest of 12% nominal compounded yearly, meaning when we say that the compounding period is yearly, meaning in a year, because the nominal rate is always expressed as yearly or per year, meaning if the interest is to be compounded yearly, meaning there is only one compounding in a year, then our number of periods per year is 1. Well, it may not yet be clear of what is meant by period here. Okay, that will become clearer in the following illustration. Meaning the interest, which is the interest per compounding period, which I call I sub m, is equal to 0.1 divided by 1, which is equal to 0.1 or 0.12. Again, it might not be clear yet because it may become clearer on the following illustration. So we can compute the future worth of the money say after a year to be equal to the principal amount times 1 plus the interest raised to the power of period, which is in this case is 1, because we are only referring to one compounding, which is 1 year. Or we'll have 1.12 of the principal amount. Now, this will become much clearer when considering another illustration. Suppose the bank is offering a semi-annual compounding, meaning the nominal interest is the same 12%, but they will compound the money every 6 months. Semi-annual means every 6 months. Annual means yearly. Semi means half. So meaning for a total or for a period of 1 year, a year is composed of 12 months and the bank will compound the money every half of the year. Meaning for a period of 1 year, this money in this bank will compound twice, meaning the number of period is 2. Meaning if the money in the bank is deposited in January 1, at the end of June, say June 30, the money will earn its first interest. And then at the end of the year, that is after another 6 months, the money will earn its second interest. But what is that interest? The interest is not 12%, but the interest is 6%. Meaning after 6 months, meaning on June 30th, your money will earn 6%. On December, the money again earns 6%, including the interest earned from June 30. Or in formula, if we compute the total amount of money in the bank after a year, it will become principal amount times 1.06 times 1.06. This is the amount of money earned on June 30th. I multiply it again by 1.06 to get the amount of money earned or amount of money at the end of the year. That's why we have a square in here because of the presence of two 1.06. Or the total amount of money in the bank after a year is 1.1236 of the principal amount. Now, let us consider that another bank is offering an interest of 12%, but the compounding is quarterly, meaning the total number of compounding is 4. What does that mean? It means that after first 3 months, because a quarter is composed of 3 months. First 3 months is for first quarter. Second 3 months is second quarter. Third 3 months is a third, and fourth 3 months is the fourth quarter. Every quarter is 3 months, and there are 4 quarters, and 4 quarters is 12 months, that is 4 years. Now, the interest per quarter, which is I sub m, is not 12%, because 12% is the nominal interest. It is only used as the basis of the computation of the actual interest per compounding. Since the compounding is every quarter, the interest per quarter must be, of course, we need to divide the 12% yearly nominal interest by 4, and that will be equal to 3%. Meaning, the money in the bank will earn 3% after first quarter. After another quarter, another 3%. In fact, there are 4 quarters, meaning the money in this bank will be compounded 4 times, meaning we multiply the principal amount by 1.03 4 times. Or we can say that at the end of the year, the total amount of money in this bank will be 1.12 1.1255 of the principal amount deposited. Okay, so assuming that a certain bank or another bank offers the same nominal interest of 12%, but willing to compound the money monthly, meaning the total number of period of compounding is now 12, meaning for every month the money will earn an interest of how much? Meaning every month the money will earn 1%. But it is compounded, meaning on the second month it will earn another 1%, including that interest of the previous month. Meaning, if we compute the total amount earned after a year, we can write it this way. Or, if we compute the value, we'll have this amount. Okay, so in general, if there are m period of compounding in a year, then we can say that the interest per compounding must be equal to the nominal rate R divided by m. So if this is now the true interest per compounding, meaning we can now determine the future amount after a year using the same formula, principal amount times 1 plus the interest per compounding period raised to the power of number of compounding. The number of compounding in this case is also m. We are referring to a year period in this case. So meaning m is the number of periods in the year. Okay, let us consider the total amount earned of money in this case, the quarterly interest. The interest earned by the money, as you can see here, the initial amount or the principal amount is P. At the end of the year, the amount of money has become 1.1255 of P. It means that the amount that the money has earned not only 12%, but 12.55%, meaning that true interest earned by the money after a year is not 12%, it is greater than 12%, meaning the actual interest is always greater than the nominal interest. So how do we compute the actual interest earned given the nominal rate? Okay, let's consider an illustration here. If after a year for a quarterly compounding, after a year the amount of money earned is the amount of money accumulated is 1.1255 of P. If we subtract P, then what we get is the total interest earned. If we divide it by P, meaning we are computing the amount increased divided by the principal, which would mean an interest. So this is what we call the true interest or the effective rate or also the effective interest. It is also called the true interest. Now we can divide the upper or the numerator denominator both by P and we get this quantity. So in general, or in this case, we can say that the interest earned by money is not only 12%, but 12.55%. This is the true interest for quarterly compounding. In general, if the total amount of money earned after a year is equal to this amount, and considering that the amount invested is only 1 peso, we subtract 1 peso in order to get the amount earned by your 1 peso. Divide it by your 1 peso, we get the interest. Since dividing by 1 is simply equivalent to this expression, then we can say that this is now the formula to compute for the effective rate or the true interest. So, recall or remember this formula to compute for the true interest or the effective rate. Okay, let's proceed. For example, um, another bank offers 12% nominal rate, but the compounding is weekly. We will observe what will happen to the future amount. As you can see from here, the compounding is yearly. This is for semi-annual, quarterly, monthly. As you can observe, there is an increase in the coefficient of P, meaning the amount accumulated is becoming greater for increasing compounding or for a more frequent compounding. So 12.55, 12.67, and for weekly, we have 1.1269. For daily, this now becomes 1.1275. And for hourly, this now becomes 1.1275 of P. As you can observe, for daily and hourly, there seems to be no difference at all. Actually, there is. It is because of the number of approximation we use in this case is only for decimal places. For per minute, as you can see again, there seems to be no difference, but there is at um, the somewhere here on the maybe 10th decimal places. We may actually continue the compounding process. So let's say uh, there is a bank somewhere here. It says that they are offering an interest of 12%, but the compounding is continuous, meaning they will compound your money every moment in time. So what will happen to the future amount of the money? Okay, if the compounding period is every moment in time, it means the compounding is continuous. The number of period of compounding per year cannot be counted. That will be infinite. And the interest per period can be expressed by this expression, which we cannot define yet. But we can compute the future worth of money using the same formula. If the principal amount is P, then we'll have I1 plus the interest per the nominal rate divided by the total number of compounding raised to the total number of compounding is equal to some unknown number P here. Now we can show that there is that amount of money accumulated even if the money is invested in a continuous compound. Let us show in here. So this is the formula to compute for the future amount of money compounded m times in a year. Now we can rewrite this as 1 over mr. We can divide m by r and then multiply it by r to retain the quantity m here. Now we can rewrite this expression here. If we replace the principal amount to be equal to 1, say 1 peso, to make the expression simple, and then since m over r is equal to m over r, then we can replace m over r by some variable, say variable x, then we can have this final expression. If you put this expression in your calculator, 1 plus 1 over x raised to the power of x, and evaluate the expression by substituting a large value of x, say input 1 plus 1 over x raised to x in your calculator, press the calc button, and then enter 999,999. What you will get is a number close to this number, 2.718281828. This number is an Euler's constant, which is represented by the constant E. So we can write the formula as F is equal to A raised to the power of R. Or we can say that the effective rate per year if the compounding is continuous, meaning the bank will compound your money every moment in time, will be equal to this quantity. Subtract 1 from this future amount, what you get is the amount earned by the money or the actual interest earned by the money. We can also compute the total amount earned if the investment is not only 1 peso. If the investment is some amount, P, then we write the P here. Since this amount is the amount earned for a period of 1 year, and since what we want is the for a total period of n years, so we have to write n here. Okay, let's try this. What is the accumulated amount after 3 years of 6,500 invested at the rate of 12% per year, compounded semi-annually? Okay, the question is, what is the future amount? We have the present amount 6,500. The number of years is 3 years. The R is 12%. The number of compounding per year is 2. So this is a compounded semi-annual. Now this is our formula. Principal plus 1 plus the interest per compounding. The interest per compounding can be computed by the nominal rate divided by number of compounding. Since nominal rate is 12%, if we divide it by 2, meaning the interest per compounding is 6%, meaning every 6 months the interest is 6%. Raised to the power of how many compounding do we have? In every year, we have 2 compounding. But it is not only 2 compounding because the money is invested for 3 years. It would mean that the money will compound 6 times. That is, for the first year, it has 2 compounding. For the second year, another 2. And for the third year, another 2. Meaning a total of 6 compounding. So we get 9,220. If the nominal interest rate is 3%, how much is 5,000 worth in 10 years? In a continuously compounded account. So for a continuously compounded account, we have here the present amount is 5,000. The number of period is 10 years. The nominal rate is 3%. The number of compounding is infinite. In fact, it is continuously compounded. We have a special formula for that. So we have F is equal to PERN. So our result is 6,750. What nominal rate compounded quarterly could be used instead for 15% compounded semi-annually? Okay, what does that mean? Meaning we have a money which is compounded quarterly. No, we have a money which is 15% compounded semi-annually. And then we want to convert that to a quarterly compounding. What must be the nominal rate? Okay, what is the idea to use? The idea to use is the effective rate. Meaning the effective rate of these two compounding must be the same. Now this is the formula for the effective rate. Effective rate, say I will compute the effective rate per year to be equal to 1 plus the interest per compounding raised to the power of number of periods per year less 1. Okay, we'll use this formula to compute the effective rate. Now I will compute the effective rate of the 15% compounded semi-annually, and this is its effective rate. 1 plus, since this is compounded semi-annually, meaning the compounding every 6 months is 7.5%, raised to, since there are 2 compounding a year, so we have 2 minus 1. Now, this effective rate must be equal to the effective rate when it is compounded quarterly. Now, for quarterly compounding, the effective rate must be equal to 1 plus whatever is the designed nominal rate divided by 4, because this is quarterly, raised to 4 minus 1. So we equate these two quantities By equating this to quantity, we arrive into an equation with one variable. In this case is R. Now we may use the shift-solve function of your calculators to solve for the value of R. So the nominal rate is 14.72%. Okay, let's try these exercises. A father wishes his son to receive 500,000 10 years from now. What amount should he invest now if it will earn interest of 12% compounded annually during the first 5 years and 15% compounded quarterly during the next 5 years? Okay, the target amount 500,000. The question is, what is the amount? What amount should he invest now? Okay, assuming that the amount invested now is P because we don't know the amount. First, it will earn an interest of 12% for the first 5 years, meaning after 5 years, this amount of money will become 1 plus 0.12 raised to 5. 12% is the interest per year. The compounding is yearly. Raised to the power of 5, that is the number of compounding. Now, after 5 years, this amount of money will compound 15% quarterly for the next 5 years, meaning we need to multiply it by 1 plus 0.0375. Why 0.0375? Because we will compute the interest per quarter. The interest given for the next 5 years is 15%. Now I will divide 15% because this is a yearly nominal rate. I will compute the actual interest per quarter. So I will divide 15 by 4. What I get is 0.0375. So after 5 years, this is the amount of money accumulated. After first quarter, this is for the first 5 years, and then another plus a quarter, this amount of money will earn this quantity. Then another quarter, and so on for a period of 5 years. Meaning this quantity, because this quantity will serve as the principal for the next compounding, this quantity will be compounded quarterly according to this factor. How many factor of 1.0375? That is 4 in a year for 5 years. That is 4 in a year for 5 years. That is 20 compounding of 0.035. Then, according to the statement, that the amount withdrawable after 5 years or 10 years is 500,000 pesos. So computing for the value P, we have 135,800 pesos. Okay, so next, you deposit 1,000 pesos into a 9% account today. At the end of the 2 years, you will deposit another 3,000. In 5 years, you plan a 4,000 peso purchase. How much is left in the account 1 year after the purchase? Okay, this is what happened to this uh, problem. First, we have 1,000 pesos. We deposited it for 2 years at the rate of 9%. After 2 years, the amount of money is this quantity. And then after 2 years, we added 3,000. This is now the total amount of money in the account after 2 years, after depositing 3,000. And then uh, at the end of 2 years, you will deposit another 3,000. In 5 years, it means that 2 years after depositing 3,000, meaning this entire quantity will earn 9% for the next 3 years. I mean, this is at the end of 2 years. At the end of 2 years, I mean, we deposited another 3,000. It means that in order to in order to go to the fifth year, we need to add 3 years more. So we multiply it by 1.09 raised to the power of 3. In 5 years, you plan a 4,000 purchase. So here, after 5 years, you plan a purchase of 4,000. So you go to the bank and withdraw 4,000. So we withdraw 4,000 here. Okay, this is the amount of money left in the bank after 5 years. Now, since there is still some amount of money in the bank after withdrawing 4,000 pesos, then at the end of another year, this entire amount will earn another 9%, which is 1,550. Correction, this is 4,000 pesos. Okay, next problem. A man bought a lot worth 1 million if paid in cash. On the installment basis, he paid a down payment of 200,000, 300,000 at the end of 1 year, 400,000 at the end of 3 years, and a final payment at the end of 5 years. What was the final payment if the interest was 20%? Okay, the owner of the lot is selling the property for 1 million pesos. Okay, meaning the owner of the lot wants his property to be sold now at 1 million. But since you do not have enough cash for this one, you as the buyer proposes another payment scheme in a form of installment. You said that you're willing to pay now 200,000 pesos, which we call down payment. And then you will pay at the end of the first year another or at 300,000 pesos and 400,000 pesos at the end of the 3 years. And you decided to pay the final payment on the fifth year, which is the unknown here. The question is, what must be the final payment? Okay, so this is the actual amount or the cash price of the property. This is the proposal of the buyer. Now the question is, what must be the final payment? The owner of the lot is also investing his money at the rate of 20%, meaning if the owner of the lot receives 1 million now, he will invest this money in maybe another business or in a bank at the rate of 20% per year. Then the owner of the lot at the end of the fifth year would expect that his 1 million by then will become 1 million times 1.2 raised to the power of 5, which is equal to 4,488,320. Okay, now the owner of the lot says that we will compute your payment your payment scheme such that its effect is equivalent to 4,488,320 after 5 years. That is in order to be fair. Why? Because there is an available investment for this owner at the rate of 20%. Okay, now let us consider the 200,000 pesos. If you pay me 200,000 pesos now, that 200,000 pesos after 5 years will be equal to this amount because I will invest that to my business at the rate of 20% per year. If you give me 300,000 pesos at the end of the first year, that amount after 5 years will become this amount because I will invest that to 2%, 20%. That is 4 years. And if you pay 400,000 at the end of the third year, I still have 2 years for that money to compound. And that will be the amount of money after or at the end of the fifth year. And your final payment is X. Now, this total payment at the end of the fifth year must be equal to 4,480,320. So it means that we must equate these two quantity. So meaning the 1 million in this case must be equal to the future amount accumulated by all of these payments. Likewise, we may also, okay, if you can see, the method of computation here is like this. We are comparing the two cash flow. One, we have the original cash flow, which is the present worth of the the present worth of the property. We have another cash flow, which we call the equivalent cash flow. The equivalent cash flow is an installment. Now, in order for us to compute the X, we must equate the two cash flow because the two cash flows are equivalent. If the two cash flows are equivalent, meaning if we project the first cash flow to some period, like say on the fifth year, and we project also all of the cash flows on the equivalent cash flow on the same period, we must yield the same amount of money. Like for example, this way, it is projected on the fifth year, and also we have also projected all of these cash flows on the fifth year. Then, since these two cash flows are equivalent, then they must be equal. Then X can be computed. Or we may also project this on the year zero or the present year here, meaning the present worth of the first cash flow is obviously 1 million. Okay, we may actually project that on any period you like say on the second year. It depends on the year of convenience. Convenient in calculation. But in my case, maybe the convenient is the year zero. So I will equate the present worth of the first cash flow, 1 million, equate that to the present worth of all of the cash flows of the equivalent cash flow. 200,000 is already at the present year. That's why we have 200,000. Now we project 300,000 to year zero. That must be 300,000 divide 1.2. And then compute the present worth equivalent of 400,000 to year zero. We divide it by 1.12 raised to, this is 3 years from year zero, plus the present worth equivalent of x, which is x divided by 1.2 raised to, this is 5 years from year zero. Okay, we have x here, we have x here. If we compute the value of x for both of these equations, we will arrive into the same answer of 792,000. Okay, I will now proceed to ordinary annuity. Suppose that you are planning to deposit a portion of your salary to the bank at the rate of 10% per month. So since we are talking about salary, it means that your salary comes at the end of the month. Assuming that today is January 1, then your salary will arrive on January 31st. Assuming that you are planning to invest or you're planning to deposit 10,000 of your money to the bank at the end of the month. So we mean that at the end of the month, on January 31st, you deposited 10,000 to the bank. Next, at the end of the February, upon receiving your salary, you deposit another 10,000 to the bank. At the end of March, you deposited another 10,000, another 10,000 for April, and for May, and for June. Assuming that this bank is offering 10% interest compounded per month, then at the end of the 6 month, how much money is accumulated in the bank? Or how much money is available for withdrawal in the bank? Okay, so let's compute that. First, let's compute the total amount of money accumulated by 10,000 pesos deposited on the last or on the end of January. That's equivalent to, or that's the interest, or that's the amount accumulated for 5 months. For 10% per month, that is equal to 10,000 times 1.1 raised to the power of 5. Now, the amount of money deposited on the end of February is equal to that quantity. For the end of March, April, May, and June. Now, if we compute the total amount accumulated for the 6th month through this uniform deposit, we will have 17,000 pesos. Now, the 17,000 pesos is the equivalent single cash flow. Instead of drawing another cash flow, we can actually superimpose our cash flow in our existing cash flow, except that we invert its direction. So if all of our cash flow is directed downward, so this cash flow belongs to our original cash flow. There is an equivalent cash flow, which is the equivalent of all of these cash flows, which is a single cash flow, which is 17,000 pesos, which is not part of this original cash flow. In order to make our cash flow simpler, we simply superimpose the other cash flow, which is 70,000. But instead of going downward direction, we place it in a vertical direction to mean that this is a separate cash flow, but equivalent to our original cash flow. Okay, so let's develop the formula to compute the total amount accumulated at the end of the period. Assuming that the amount deposited in the bank is A for every end of the month, then we have a uniform cash flow of A. As you may observe that our cash flow all occurs at the end of the period. There is no cash flow at the beginning of the period. If the cash flow starts at the beginning of the period and the cash flow are uniform, this cash flow is called an ordinary annuity. Okay, if we compute the total amount earned by all of this cash flow at the end of the period, then we can use the same analog. We have A times 1 plus I raised to the 5th power, the 4th, 3rd, 2nd, 1st, and lastly is the A. And then we compute all of these quantities. As you can see, there is a common term here, which is A. We can factor out the A, leaving only these expressions. And then this will be, assuming that 1 plus I is our R, Then we can use this procedure or this derivation to compute for the future value of f. We'll just show them for you to have the information on why did we have this formula. Okay, so this is now the formula for the future worth of all of this uh, uniform cash flow. F is equal to the cash flow, uniform cash flow, times 1 plus I raised to the power of n minus 1 over I. Okay, what if we are computing for the present equivalent of the cash flow? Since what we have computed is the future equivalent of all of the cash flow. Now the idea is the same. We can predict all of this cash flow at the year 0. And then we'll have an equivalent cash flow P here, which may be computed to be equal to this formula. Okay? Or we may project all of the cash flows in the future, which is equal to this one, and then project it back on the year 0 by using the idea that if we have a cash flow, in this case a single cash flow of P, then this P projected at the future is equivalent to P times 1 plus I to the n according to our compounding formula. Now, since we have already converted all of our uniform cash flow into a single cash flow, then meaning this single cash flow will serve as our F, single cash flow F. Then we can compute the equivalent P by replacing our F here by this expression. So our P now may be computed by projecting the cash flow at the year 0, and our P is equal to this formula, which is finally equal to this formula. I prefer this formula because it seems much simpler to me than this expression. Okay, let's try this. How much money must you deposit today in an account earning 10% compounded annually so that you can withdraw 10,000 yearly for 6 years starting at the end of the first year? Okay, so this is scenario. We have an uniform cash flow for 6 years. 1, 2, 3, 4, 5, and 6. We want to withdraw 10,000 for each end of that year. So we will use this formula to compute for the equivalent cash flow. We will project all of this cash flow at year 0. And this is our formula. Our P is unknown. This is the question. Our interest is 10% compounded yearly. Our A is 10,000. Our N is 6. Substituting everything, we can compute the value. Okay, let's try this. A television set is available on an easy installment plan. The down payment is 3,000 and installment payment are 500 each, payable at the end of every 3 months for 3 years. If interest is 6% compounded quarterly, what is the equivalent cash price of the television? Okay, this is the equivalent, uh, this is the installment payment for the television. It has a 3,000 down payment and it has an installment of 500 for every quarter for 3 years. First year, that's composed of 4 quarters. Second year, another 4 quarters. Third year, another 4 quarters. A total of 12 quarters. Okay, as you can see, we are computing here for the equivalent cash flow at the present because the problem is asking for the cash price, meaning the cash that is equivalent to all of these cash flows. So this is the equivalent cash flow. We have here a cash price. We have an original cash flow here, and we have an equivalent cash flow here. Okay, in order to make it simple, we only merge the two cash flows, but we invert the direction of the other cash flow to mean that it is not part of the original. It is simply mean that it is equivalent to the original cash flow. Now we can equate the two cash flow. We can select which period is convenient for us to compute the equation. Okay, of course, since the cash price is already at the present date, we can use the present worth of the cash price. And also we can also use the present worth of all of these cash flows. So we can equate the present worth of the cash price is equal to the present worth of the down payment and the present worth of all of these cash flows. That is, X is equal to the present worth of the down payment is also the down payment, 3,000. Now here we have a uniform cash flow, the present worth of all of these cash flows is the present worth of the annuity. This annuity is an ordinary annuity because the cash flow starts at the end of the first period. So we will have 5,000 according to the formula 1 minus 1.015 because okay, why the interest, if the interest is compounded according to the problem, if interest is 6% compounded quarterly. Now the 6% here is a nominal interest. Since the compounding is quarterly, then we need to divide it by 4. 6% divided by 4 is 1.5%, and that is our interest here. So we have 1 minus 1 plus the interest per compounding is 1.5% raised to the total number of compounding, that is the total number of payments here, is 12. It so happened that the compounding coincides with the payment. That must be always the case. But if that is not the case, then we must find a way such that the compounding period compounds with the payment period in order for us to use this formula. But in this case, it's not a problem because the compounding, which is quarterly, coincides with the payment, which is also quarterly. Okay, so this is now complete and the only unknown is x, the value of x. Now let's proceed to annuity due. What is an annuity due and how does it towards the annuity due? The present worth of the annuity computed using this illustration. As you can see, that this formula is the formula for the future worth of this annuity. And by the addition of another cash flow, which is the down payment, we have now the complete future worth of the annuity due. But our concern is the present worth, not the future worth. Well, that will be easy because we can simply project all of this cash flow at the 6th year. And this is the cash flow. This is now the single cash flow. If there is a single cash flow, then we can project that cash flow anywhere along the timeline. Now, we wish to project this in the present. The relationship between the two cash flow between the two periods is according to this formula. Meaning, if this one is F, which we have computed, which is to be equal to this one, then we can relate that to P here using the same formula. So, by substituting here, we can now compute for your P. The present worth of the annuity due is equal to this formula. Anyway, it's not difficult because we can actually analyze that based on the ordinary annuity only, and then plus the uh, initial payment. As you can see, the first term here is the present worth of the ordinary annuity plus the down payment, which is the present amount. Okay, let's try this. A house and lot is being sold, and the payments are on installment basis of 400,000 each year for 5 years. If the payment are to be made at the beginning of each year, how much is the cash price of the property? Assume that the money is worth 20% compounded annually. So here is our cash flow. The first payment is 400,000 now. This is the beginning of year 1, beginning of year 2, beginning of year 3, beginning of year 4, beginning of year 5. And there is no cash flow on the 5th year. It's, there must be no cash flow here. It's a correction. Now, if we compute the present equivalent of this cash flow, then we'll use this formula. First is the present worth of our ordinary annuity. Our ordinary annuity here is the annuity from this point up to this point only, meaning our n here must be equal to 1, 2, 3, 4. It must be equal to 4. Okay, so our unknown here is P. A 400,000. Our N is 4, not 5. Our I is 20% because and it is also an annual compounding. So we can compute the value of P by direct substitution. Correct. Okay, let's proceed to deferred annuity. Deferred annuity. We'll illustrate the deferred annuity by this example. A man acquires a loan of 500,000 pesos. He will amortize his loan by 10 annual payments, but will commence 5 years after the loan was acquired. If the money is worth 10% compounded annually, what was his annual amortization? Okay, so this is the amortization of this man. The loan is 500,000 pesos and the payment will start after five, commence 5 years after the loan was acquired. Okay, after 1 year, after 2 years, because this is the end of first year, meaning it is after 1 year, after 2 years, 3, 4, after 5 years. Then for 10 years, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's a total of 10 payments. Now, the question is, what is the annual payment? Okay, but we know that the present worth equivalent of all of this cash flow is 500,000 pesos. So meaning, first we will compute the equivalent present worth of all of this cash flow. Well, we cannot project directly to year 0 because this cash flow is not located on year 1 but on year 5. If we wish to compute the present worth of this cash flow, then we must use the formula step by step. First, we'll compute the equivalent cash flow of all of this cash flow on year 4 because that is the formula for the ordinary annuity. Now, if we wish to compute the equivalent cash flow on year 4, then we'll use this formula. For the present worth of the ordinary annuity, we have A times 1 minus 1 plus I raised to negative n, where n is the number of payments, in this case is 10. Now, since this is not actually the present worth, because the present worth is actually at year 0, Then we replace it by some names. We call it L, meaning the equivalent cash flow on L, which is the present on fourth year. Meaning if we are on the fourth year already, then this is the present on the fourth year. But since we are looking for the value at year zero, then this is not the present at year in respect to year zero. Now, since this is now a single payment, then we can compute its equivalent at year zero by dividing it by, according to this formula, if we have a future amount, any future amount, and want to project it to the present, we simply divide it by this factor. This is 4 years from year zero, but our amount quantity here is this amount L. So we can now compute for the value of P. So substituting everything here, we have 500K, which is the present worth, is equal to our L, which is equal to this quantity, divided by this quantity. Then computing A will get the value of A. Okay, so let's now proceed to perpetuity. What is a perpetuity? Perpetuity is actually an annuity. It is an unending annuity. Assuming we have a cash flow that starts at the end of the first period and continue indefinitely. This is a perpetuity. The question is, what is the present worth equivalent of all of this cash flow? Well, we'll use the same formula as that of the annuity. Here, the present worth of the annuity is A times 1 minus 1 plus I raised to the power of n over I. But take note that our n here is an infinite number. If this number is infinite, 1 plus I raised to negative infinite is 0. So meaning this expression is reduced to 0, leaving only 1 over I. That's why our P is now reduced to P over I. Take note that the perpetuity has no future worth equivalent because the future is not defined, only the present worth. Okay, let's consider this problem. How much money must you deposit today in an account, earning 10% compounded annually so that you can withdraw 25,000 yearly indefinitely starting at the end of the 10th year? Okay, so you want to deposit amount today and you want to withdraw money at the end of the 10th year amounting to 25,000 yearly indefinitely. Is that possible? Let's try. This is the amount of money that you want to receive from the end of the 10th year up to forever. Now, we'll compute the present worth equivalent of this one, but the present worth equivalent of this money is located on year 9, according to our formula in the ordinary annuity. So let's project that amount to year 9. That amount is equal to A over I. And since this is the future amount with respect to year 0, we can compute its equivalent at year 0 using the relationship. Okay, we replace P by L because this is not actually present. This is the equivalent cash flow on year 9. Now this is L, and then we project it in year 0. On year 0, if we project the L, we'll use the relationship because if we have an F here, we can compute its equivalent P here using the same formula here. Now, since we have already the F, which is equal to A over I, then we replace that here. We now use N to be equal to, here our N is 9 because this single cash flow is located on the 9th or the end of the 9th year. Don't use 10 because the ordinary annuity has been shifted 1 year earlier according to this formula of the ordinary annuity. That's why the value of n that is to be used here is 9. So we'll have the present worth to be equal to this formula.